I'm so glad you could join me here again at Math Rocks with Mr. Cox for another math video. This one, as the image may suggest here, is about parabolas. And we're going to be looking at the three different forms of quadratics or parabolas and what they tell you about the either y-intercept or the x-intercepts or the vertex, and also how to switch back and forth between each of the three forms. Let's get it on! It turns out that there's three different forms of quadratics, or what we also call parabolas. One is called the standard form, we have the intercept form, and also the graphing form. And these are examples of what those might look like. So standard form is what you're going to most commonly see. And what this one will tell you right away is it will actually tell you what the y-intercept, if only you know how to interpret what you see. And the y-intercept, as you know, is always 0, comma something. So if you were to plug in a 0 into each of these x's here, you're going to get 0. So this last number, the constant, is actually our y-intercept. So that's what the standard form will tell you about the graph right away just by looking at it. The intercept form will actually tell you something a little bit different. It's going to actually tell you the x-intercepts. And in this case here, you're going to look at each of the parentheses. You're going to ignore the number, the multiplier out in front. But ask yourself, what would make each of these values, or what would x need to be in order for this parentheses to be equal to 0? So of course, it would have to be -2 because -2 plus 2 is 0, which means one of our x-intercepts is -2, comma 0. And then the other one, what would make this parentheses equal to 0 would be x equals 3. So that means our other x-intercept is 3, comma 0. So that's intercept form. And the final one is graphing, or sometimes we call it vertex form, because it actually tells you the vertex. If you look at the parentheses again, once again, we look at it in terms of what would x need to be to make this parentheses equal to 0? Well, it will need to be, I'm going to write out vertex here, by the way, first, it would need to be -5. And then whatever number you see out here, in this case is a +9, that is going to be the y-coordinate. So that would be our vertex. As it turns out, standard form honestly is not that useful. I know it does tell you the y-intercept, but intercept form is much more useful because from it you can determine what the x-intercepts are. So if we have this equation here, y equals -2x squared plus 12x minus 10, we are going to actually convert it over into intercept form. So the first thing you want to do is ask yourself, well, what do all of these numbers have in common? Well, they're all even. And also we have this is a -2 besides being even. So what I'm going to do here is I'm going to write this as y equals, and I'm going to factor out the -2. So this will become -2 times x squared would give us -2x squared. -2 times -6x would give us that. And finally, -2 times a +5 would give us the last number, the constant. And then what we're going to do is we're just going to focus on what's inside the parentheses here. And we're going to go back to factoring in other videos. If you don't know how to do this already, I have some great videos on how to factor. If it's just x squared, this actually turns out to be really easy. All you need to do is a diamond problem. So if you think about it this way, we're going to take this last number, the 5, the constant, put it on top, and we're going to take the -6, put it down here on the bottom. And what we're doing is we're going to be asking ourselves, what would multiply to be 5 and what would add it to be -6? And the only thing that would work there is -1 and -5. And so once you have that, what it means is we can factor the x squared minus 6x plus 5 into x minus 1 and then also x minus 5. And those numbers, -1 and -5, come from completing the diamond problem over here. And then finally, to finish this all out, if we use the zero product property, we would go ahead, put a 0 here, which would mean either x minus 1 is equal to 0 or x minus 5 is equal to 0 as well, which means x is 1 and x is 5, and that means therefore that our x-intercepts are 1, comma 0 and 5, comma 0. So it's much more useful than just looking at this equation and saying, hey, I know my y-intercept is going to be 0, -10. Having the x-intercepts gives you more information. Also, you'll know the vertex is halfway in between, so halfway between 1 and 5 is 3. So I know my vertex is going to be 3, comma something, and I can figure that out. As always, if you like what you see, please like, comment, or subscribe. Thank you, and now back to part 2. And you also want to be able to convert from standard into graphing form, which we also call vertex form. It's going to work a little differently here in how this conversion works. First of all, we're going to go ahead and isolate just the x squareds and the x's on one side. So to do that, I'm going to add 10 to both sides. So now I get y plus 10 equals negative 2 x squared plus 12x. And like in the other conversion, we're going to see what these have in common. And I'm going to go ahead and I'm going to factor out the negative 2. Now let me go ahead and finish this side over here too as well. And if we factor out a negative 2, we're going to get x squared and we're going to get negative 6. And then what we want to do is we're going to be completing a square. So to do that, I'm going to go ahead over here and I'm going to make myself what looks to be pretty much a square. And I'm going to put my 4 boxes inside there. So I'm going to take my x squared right at here. I'm going to take this negative 6x, cut it in half, and put that half, negative 3x, in each of these boxes. So if I were to do that, I'm going to get x and x times negative 3, and this is negative 3. And so to complete my square, what I'm going to need to do is I am going to need to add 9. So let's go ahead and we're going to go ahead and add 9. And you would think that if you add 9 on this on this side of the equation, you would add 9 over here. But actually, just follow along here. I'm actually going to subtract 18. Why negative 18? And that's because I know we added 9, but remember we have a multiplier out in front. Negative 2 times positive 9 is negative 18. So really by adding 9, we're really subtracting 18 over here. And that's why you have to do that over here. I'm going to go ahead and add these together. I get y minus 8 equals negative 2, and then I'm going to write x squared minus 6x plus 9 as a perfect square. So that will be x minus 3 quantity squared. And then finally, to wrap this all up, I'm going to add 8 on both sides, and therefore I get y equals negative 2, the quantity x minus 3 squared, and then plus 8. And now that we're in graphing form, aka vertex form, that means our vertex is going to be 3, because that makes this equal to 0, if x is 3, and then comma 8. So that would be our vertex. And then finally, to put this all together here, we had our 3 forms. The first form, standard form, told us what the y-intercept is. The second one, which is our intercept form, told us where the x-intercepts are, right here and here. And then finally, the vertex form told us where our vertex is. So now what we need to do to finish this out, to actually complete our graph, we're going to go ahead, and by the way, I've already put the first 4 points on here that we already figured out from the other forms. We just need a few other points. So because this is our vertex right here, what that tells me is that these 2 points, with x being 2 and x equal 4, because they're both 1 away from 3, are going to have the exact same y values, just like these 2 are going to have the exact same y values, 0 and 0, which means also if this is 0 comma negative 10, this also must be 6 negative 10. And I'm going to go ahead and put that point right here. So that's my 6 negative 10. And now let's go ahead and let's plug in either a 2 or a 4. So up here, what I'm going to do, I actually prefer the intercept form for doing this. I'm going to use this one right here. So if I use a 2, what would happen is this would become a 2, and this x would also become a 2. And so I'm going to get, I have my negative 2 out in front. 2 minus 1 is just 1, and 2 minus 5 is negative 3. I'm going to go ahead and put that in parentheses as well. And if we multiply negative 2 times negative 1 times negative 3, we get a 6. So that means both of these are going to be comma 6. So I'm going to go right 2 and up 6. 1, 2, 3, 4, 5, 6. And if I go right 4 and up 6, there we go. We would have our parabola. I'm going to do my best parabola curve here. So I'm going to go straight up through those points right there. And then I'm going to go back down through here as best I can. Not the straightest, but it'll work. And there we have it. There is our parabola using the information from the 3 forms, plus just getting a couple extra points here, and then we're all done. Hope you got a lot out of this video. Thanks for watching.